Alright guys, so in this lesson we are going to talk about building functions from functions. This is going to mean combining functions with operations and composition of functions where we put one function inside another function. So first we're going to look at combining functions with operations. Here we're talking about combining the equations of functions with addition, subtraction, multiplication, and division. We're also going to be talking about the domains of these functions. So when we're talking about the domains of the functions that are the combination of two functions with addition, subtraction, and multiplication, we're basically going to say that we have all of the restrictions of the two functions that we're bringing together with the given operation. With division, we also have to watch out for the function in the denominator, where we can't have that function in the denominator equaling 0. So right here, the first thing we're going to do is go through and define the domain for a given set of functions that we are going to be combining with operations. Here we've got our s of x, which is x plus 2. And we can see that we've got no domain restrictions to violate, right? So right here we can say that our domain is going to be negative infinity to positive infinity. With our h of x, we've got 1 over x minus 2. Here we know that we can't have any x value that will give us 0 in the denominator. So x cannot equal 2. And that means that we've got a domain of negative infinity to 2, union with 2 to positive infinity. And finally, right here, we have the square root of x. And of course, we know we can't have any x value that will make us negative under an even radical. So here we're saying x cannot be less than 0. And that would give us the domain for this last function of 0 to positive infinity. So right here, what we're going to talk about is basically how we want to think about combining these functions with the given operations we're seeing right here. For our first function, we've got h plus d of x. Now, what this means when we say h plus d of x is the equation that defines h of x plus the equation that defines d of x. So we're literally saying h of x plus d of x. Now, right here, when we're combining these two functions, we actually want to put parentheses around the equations for h of x and d of x. So right here, I'm going to have parentheses for h of x plus, and then parentheses for d of x. Now right here, I can plug in my h of x, and I have h of x as 1 over x minus 2, and then plug in my d of x. So there's h of x, and then plug in my d of x, and our d of x is the square root of x, right? Now, right here, the parentheses are important. If we were thinking about combining two functions with, let's say, subtraction. So let's say we had h minus s of x. Well, right here, that would be h of x minus s of x, right? And right here, if we combine without parentheses, we would have 1 over x minus 2 minus, right here, x plus 2. Now, of course, this is a lot different than when we have parentheses. And really what we're saying is the quantity for s of x is being subtracted for the quantity from h of x. So really, it's this entire number that we get when we plug in the x that's being subtracted from the h of x. So we need those parentheses there. And right here, when we take down our parentheses, when we're simplifying, we'll have 1 over x minus 2, and then we distribute the negative through and get minus x minus 2. So just combining the equations that defines the functions without using parentheses can give us different functions than what we actually have. This is h minus s of x. Right here, we cannot say that 1 over x minus 2 minus x plus 2 is h minus s of x. So parentheses are important when we're combining the two functions with a given operation. And right here, what we're going to do is immediately after we combine the two functions with a given operation, we're going to evaluate the domain at this point. And basically what we're going to be doing is getting the domain restrictions from the two equations. So immediately for this first equation, our h of x, we're saying x cannot equal 2. And for the second equation, that square root of x, we're saying x cannot be less than 0. So right here, we're basically saying we can't have any numbers less than 0. So right here, we're starting at 0. And then right here, we can't have 2. So we go up to 2, not including 2. So we'd say 0 to 2, and then union with 2 to positive infinity. Now again, right here, for all the operations except division, we can basically just look at the domain restrictions for the two functions we're combining. And with division, we actually have to think about any x values that would make that denominator equal to 0. And we'll look at that in our next problem. So right here, we've combined our functions with the given operation, and we've still got these parentheses. What we want to do next is simplify the function. And essentially right here, what that's going to mean is just taking down the parentheses. Now for our addition right here, it really doesn't matter. We basically take down our parentheses and we really have the exact same thing, right? We've got our h plus d of x as that 1 over x minus 2 plus the square root of x. But parentheses is just a good habit to get into for situations like the one we're seeing down here, where that subtraction is going to have to be distributed through to both terms. This function right here would be our h plus d of x, and we would say that it has the given domain that we just found right here. All right, so let's look at our next function. So here we have s divided by h of x, and so this is of course going to be the function s of x rather divided by the function h of x. And right here, we're basically going to combine the two equations that define the functions with division. And we're setting up our parentheses. So we've got parentheses for the numerator, parentheses for the denominator. Now right here, our s of x is x plus 2, and our h of x is 1 over x minus 2. Now right here, immediately we're going to look inside our parentheses for domain restrictions, and then we're going to think about the domain restriction we're going to get from the variable expression in the denominator. So right off, we don't have any domain restrictions for our s of x, rather. There's nothing that's going to give us problems there. But in our denominator, we know that x cannot equal 2. Now, if we look at the combination right here, we're also saying that we can't have any x value that will make 1 over x minus 2 equal to 0. But if we think about this, there's no x value we can plug in that is actually going to be able to make this expression equal 0, right? If we plug in 0, we've got negative 1/2. If we plug in 2, we're already undefined because we're dividing 1 by 0. And actually, we've already said that that x value can't be in our domain. So really, the domain for this function is only going to have the domain restriction that x cannot equal 2. And so right here, we would say the domain would be from negative infinity to 2, union with 2 to positive infinity. And that's the domain. Now, simplifying here is going to mean a little more work. So right here, what we're going to do is say, if we're looking at the combination of functions here that we're seeing with division, we're seeing that we're actually dividing by a fraction. And when we divide by a fraction, we say that that is equivalent to the multiplication of the reciprocal of that fraction. So right here, we're saying that our s divided by h of x is actually going to equal x plus 2, and then times the reciprocal of our denominator, which would be x minus 2. So right here we get x squared minus 4 as the simplified function of our s divided by h of x. Now basically what we're saying here is that this right here, this equation, defines our function on this domain. Now notice that the domain restriction that x cannot equal 2 would not be a domain restriction for this equation right here. But remember that our function is actually defined as the division of s of x by h of x, and there we do have the domain restriction that x cannot equal 2. So really what we're saying is that our function is going to be x squared minus 4 on the given domain. And if we type this guy into the calculator, if we typed our original function into the calculator, we would actually get a graph that looked like this. A parabola, the parabola of x squared minus 4 that is undefined at 2. And you wouldn't be able to see that hole from the graph on your calculator, but if you went to your table and looked at the function value for 2, you would see that it would be undefined at 2, right? So this is actually the graph of the function. And right here we would say that it's exactly the graph of x squared minus 4, where we're undefined at the x value of 2. Right? Now, why would we do this? Well, right here, simplifying is actually giving us an easier function to graph, and then we just know that it's going to be on the domain that we defined way back here when we first brought our two expressions together with the given operation. All right, guys, so we're going to have you guys try this next page. I want you guys to go through and find the domains for each of these functions and then combine these functions in the given ways. Now, most of these functions, these combinations of functions are pretty easy to read. We've got addition, subtraction, multiplication, and division. This last one takes a little bit of explaining. Right here, when we say g of x, that's g times g of x. So really, this guy is g of x times g of x. Now remember, I want you guys to use those parentheses when you're combining the functions with the given operation, and then I want you to define the domain immediately when you've got those two functions in their parentheses. And then after that, I want you to simplify, take down the parentheses, distribute through the negative, or simplify however you would need to. All right, so pause the video here, guys, and we'll come back and take a look at this in a second. All right, guys, let's take a look at these combinations of functions. We've got our initial set of functions, f of x, k of x, and g of x. For f of x, we've got x squared plus 4, so no domain restrictions to violate there. We can see our domain is negative infinity to positive infinity. For our k of x, we've got 1 over 2x. Here, we can't have x equal to 0, because that'll give us 0 in the denominator, so our domain is negative infinity to 0, union with 0 to positive infinity. And for our g of x, we've got the square root of x plus 1. So here, x cannot be less than negative 1, or we'll get a negative under our even radical. And so our domain is from and including negative 1 to positive infinity. So for the most part, these combinations of functions are pretty intuitive. Looking at the sum of our functions, we've got f of x plus g of x. So that's, again, the equation for f of x plus the equation for g of x. At this point, we want to look at our domain restrictions for each individual function. We've got no domain restrictions for f of x, but g of x, of course, is a place where we can't have x less than negative 1. So our domain is from and including negative 1 to positive infinity. And then for this guy, simplifying is just going to mean taking down those parentheses. So right here, we've got f plus g of x as x squared plus 4 plus the square root of x plus 1. With the difference of functions, we've got f minus k of x, and so that's f of x minus k of x. So we've got the equation for our f of x minus the equation for our k of x. No restrictions for f of x, but k of x right here. We cannot have x equal to 0, so our domain is negative infinity to 0, union with 0 to positive infinity. And again, right here, all simplifying is going to mean for this expression is taking down the parentheses, and we've got x squared plus 4 minus 1 over 2x as the simplified expression. Now, we could get everything to be one rational function here, but really this is simplified enough for us. All right, so product of functions, we have g times k of x, so that's g of x times k of x, so that's the square root of x plus 1 times 1 over 2x. And right here we can see that from our g of x, we cannot have x be less than negative 1. And from our k of x, we cannot have x equal to 0. So right here, excluding all x values less than negative 1, we will start our domain at negative 1, and we'll include that. And then we can't have x equal to 0, so our domain is going to go from and including negative 1 to 0. We take out 0, and then union with 0 to positive infinity. And for simplification here, we could just multiply that square root straight into the numerator. So we get g times k of x as the square root of x plus 1 over 2x. Finally, right here, we've got our last two. Our quotient is the one that we have to watch out for. So normally when we're looking at domain restrictions for our combination of functions with a given operation, we can just look at the domain restrictions for each of the two functions that we're combining individually. But here we also have to watch out for the expression in the denominator. Here we're going to say that expression in the denominator cannot equal 0, because then we'll be dividing by 0, and of course that's another domain restriction. So right here we've got f divided by g of x, so that's f of x divided by g of x. Our equation for f of x is our x squared plus 4 And our equation for g of x is the square root of x plus 1. Now right here we're saying no restrictions for the numerator, but in our denominator we know we can't have x be less than negative 1. And then because that square root of x plus 1 is in the denominator, we also can't have x equal to negative 1, right? Since that would give us 0 in the denominator there. So right here, we're saying the domain is from but not including negative 1 to positive infinity. And simplifying our expression is basically going to be taking down the parentheses again. Finally, our last example is one that is probably the most interesting of all 5 of our problems. Right here we've got g times g of x. And so right here, that's the equation for g of x times the equation for g of x. So we've got the square root of x plus 1 times the square root of x plus 1. For both of these guys, we're going to say that x cannot be less than negative 1, right? And right here, that gives us a domain of from and including negative 1 to positive infinity. But then when we simplify this, we can see that we're multiplying 2 square roots of x plus 1, which gives us the square root of x plus 1 squared. The square and the square root cancel out, and so our simplified expression is actually going to be x plus 1. Now again, remember that just because this expression doesn't have any domain restrictions doesn't mean that we're not going to have the domain restriction that we had initially, because this function is actually coming from the multiplication of these 2 square roots, right, which have the domain restriction that x cannot be less than negative 1. But what we're seeing is that when we simplify this, we get the graph of x plus 1 on the domain from negative 1 to positive infinity. So again, if we type our square root of x plus 1 times our square root of x plus 1 into the calculator, or even the square root of x plus 1 squared into the calculator, what we're going to see is the graph of the linear function x plus 1 on the domain from negative 1 to positive infinity. So right here, we're actually starting at 0 at negative 1. And then right here, we would have that y-intercept of 1 and that slope of 1, and our function would look something like this on the graph of the xy axis, right? So right here, that's these problems, and we'll take a look at these on a worksheet tomorrow. I'll give you guys some more interesting examples. These are mostly just sort of warm-up, getting ourselves used to the concepts, but we'll look at some more interesting ones. All right, guys, so we'll stop the video here and go to the next video.